Ever wondered how to store and handle data in more than one dimension in programming? Well, today we're going to demystify that concept for you. Welcome to the fascinating realm of multi-dimensional arrays. Now, you might be familiar with regular arrays. They hold data in a single dimension, like a straight line. But imagine, if you will, a world where you can store data not just in a line, but on a plane, or even in a cube. That's what multi-dimensional arrays can do. They allow us to handle data in more than one dimension, opening up a world of possibilities. From creating complex data structures to simulating real-world scenarios, multi-dimensional arrays are a powerful tool in any programmer's toolkit. They're like the Swiss Army knife of data storage, so buckle up as we dive into the world of multi-dimensional arrays. Now, you might be asking, what exactly is a multi-dimensional array? Well, let's break that down. Simply put, a multi-dimensional array is an array that contains one or more arrays within it. Picture a table. The table itself represents the array, and each row and column within it is another array. This gives us a grid or matrix of data points. Each of these data points is known as an element. Now, how do we identify these elements? This is where indexes come in. Each element in the array is associated with a unique set of indexes. Think of these as the addresses for each data point within our table. In a two-dimensional array, for example, we'd have two indexes. The first index might represent the row, and the second, the column. It's a bit like a game of battleships, where you're pinpointing a location using coordinates. With these basics, we're ready to explore further. So, how do you create a multi-dimensional array? Well, let's dive right into it. Imagine a multi-dimensional array as a grid with rows and columns. You start by defining the size of this grid. In a two-dimensional array, this means specifying the number of rows and columns. Now, you've got your grid, but it's empty. To fill this grid, you initialize your array. This is like adding boxes to your grid. Each box can hold a value, and each box has a unique address, defined by its row and column number. But we're not done yet. An empty box isn't very useful, is it? So, we assign values to these boxes. You need to understand the structure of your array to do this effectively. Each value is assigned to a specific box using its unique address. Remember, the structure of your array is key. It's the backbone that supports your data. And there you have it, your very own multidimensional array. Now that we've created a multidimensional array, what can we do with it? Well, there's a lot we can do, actually. Manipulating multi-dimensional arrays isn't as intimidating as it might sound. First, let's talk about accessing and modifying elements. Just like in a single-dimensional array, we can use indices to access elements in a multi-dimensional array. But here, we need an index for each dimension. Next, we come to iteration. Iterating over a multi-dimensional array involves using nested loops, one for each dimension. This allows us to traverse the entire array and perform operations on each element. Lastly, let's look at built-in functions. Many programming languages offer a variety of functions to manipulate arrays, like sorting or reversing. These functions often work with multi-dimensional arrays too, although you may need to tweak them slightly. With these techniques, you can start to harness the power of multi-dimensional arrays. So let's get coding. Let's take a moment to review what we've learned about multi-dimensional arrays. These are arrays of arrays, a concept that's as simple as it is powerful. They are not just rows and columns, but a dynamic tool that allows us to store and manipulate complex data structures. We've understood the basics, dove into their creation, and even explored how to manipulate them. We've seen how they can be utilized effectively in various programming scenarios. They are indispensable in handling large amounts of data, making your code more efficient and readable. Whether you're working with 2 dimensions or 10, the principles remain the same. It's all about understanding the structure and knowing how to access the data you need. So don't be daunted by the complexity. Embrace it, for it is the key to unlocking more advanced programming techniques. Remember, multidimensional arrays are more than just rows and columns. They are a powerful tool in your programming